Good evening, everyone. So we have been discussing the chapter called equilibrium, right? So we have started with ionic equilibrium and we have been discussing different types of questions related to pH. And we have done with three patterns of problems, right, Kana? So first pattern is they'll be giving you the H plus ion concentration and from which we'll be calculating the pH. And second pattern is they'll give you the pH of the solution and from that pH we'll be calculating H plus ion concentration. And what was the third type? The last step we have discussed. They'll give you the concentration of any acid or base. So from the concentration of acid, we'll be calculating H plus ion concentration and from which we'll be calculating pH, right? So I'll give you an example here. I want you to calculate the pH of the solution. So for example, I have a acid which is H2SO4. Could you please name this acid? What acid is this? What acid is this, Kanna? Sulfuric acid, right? Okay. So concentration of sulfuric acid is 10 power minus 2 molarity. And I want you to calculate the pH of the solution. I've given you the concentration of this acid and I want the pH of the solution. I hope you remember all those log values, right? So if concentration of this acid is 10 power minus 2 molarity, then what will be the concentration of H plus ion? Upon complete dissociation, how the sulfuric acid will get dissociated? From sulfuric acid, how many H plus ions will be getting?
2, ma'am.
Very good. 2 times of H plus ions plus SO4 2 minus. So 1 sulfuric acid will give you 2 H plus ions. And here the concentration of acid is 10 power minus 2 molarity. And upon complete dissociation, how much H plus ions will be obtaining? Quantity of H plus ion is? If sulfuric acid is 1, then H plus ion is 2. So here the concentration of sulfuric acid is 10 power minus 2 molarity. So H plus ion is 2 into 10 power minus 2 molarity, right? So this is the H plus ion concentration. So from this, I want you to calculate the pH. So concentration of acid here is 10 power minus 2 molarity. So concentration of H plus ion is, since it is sulfuric acid, one sulfuric acid will give you 2 H plus ions. So here it is 2 into 10 power minus 2 molarity. So from which we're going to calculate pH. So what is the formula to calculate pH? What is the formula to calculate pH? Minus log of H plus ion concentration. That's it. So pH is equal to minus log of, what is the H plus ion concentration here? 2 into 10 power minus 2. So minus of, it is like log A into B. This can be written as log A plus log B. So minus of log 2. So how 10 power minus 10, how log 10 power minus 2 is? It is like log A power B, right? So this can be written as B log A. So it is minus 2 log 10. And what is the value of log 10? What is the value of log 10? 1. Very good. So 2 into 1 is 2. That's it. So we have to multiply this negative sign inside. So this is 2 minus log 2. So 2 minus, what is the value of log 2? 0.3010. So what will be the pH of the solution? Approximately it is 0.3, right? So 2 minus zero point 0.3 is 2 minus zero point 0.3 is
1.7.
1.7. That's it. Approximately it is 1.7. So this is the pH of the solution. Okay. So we have done with three pattern of the problem. One is like they'll give you the H plus ion concentration from which we'll be calculating pH. Second pattern is they'll give you the pH and we have to calculate the H plus ion concentration. And finally, they'll give you the concentration of acid or base. From that concentration, we have to calculate H plus ion concentration from which we have to calculate pH. Right. The third pattern is see 0.3 gram of calcium hydroxide dissolved in water to give 500 ml of solution. Calculate the pH of the solution. See, here they are talking about calcium hydroxide. Is it acid or base? Is it acid or base? Calcium hydroxide is a base, right? Here they didn't give you the concentration of this base directly. They've given you the way in which this calcium hydroxide solution was prepared. They've taken 0.3 gram of calcium hydroxide and they dissolved in water to give 500 ml of solution. From this data, we have to calculate calculate the concentration of calcium hydroxide, from which you have to calculate OH minus ion concentration, after which you have to calculate POH, and finally pH of the solution. So first you have to calculate the concentration of calcium hydroxide. From that, we can calculate the concentration of OH minus ion. After that, we can calculate POH. And from POH value, finally, we can calculate pH. So the first step is we have to calculate the concentration of calcium hydroxide. Here, the given data is weight of calcium hydroxide and volume of the solution. So basically, what is the formula to calculate concentration? Molarity is equal to number of moles of solute divided by volume of the solution in liters. And we can expand this, right? How this number of moles can be written as weight by molecular weight. That's it. So we have to calculate molarity. What is the weight of solute? What is the weight of solute? It is given as
0.3 grams.
very good. It is 0.3 gram. And what is the molecular weight of calcium hydroxide? Atomic weight of calcium is 40, oxygen is 16 gram per mole, and hydrogen is 1 gram per mole. Please calculate the molecular mass of calcium hydroxide. What is the value of M2? Yes, it is 74. Muthulakshmi is right. So 74 gram per mole. And what is the volume of the solution? They've given us 500 ml and we have to express it in liters. So 500 into the value of milli is 10 power minus 3 liters. That's it. So if you simplify this, you'll get the concentration of calcium hydroxide. Please simplify and tell me the value of M. Concentration of calcium hydroxide. Just give me the approximate value, that is enough. Sharmila, Muthulakshmi, Sindhamil Shelvan, Mushkan.
1 by 123, ma'am.
Come again, Kana.
1 by 123.
Okay. You're right, but I want to simplify that also. Muthulakshmi is right. What is your answer, Muthulakshmi? 0.008. So if you divide,
0.008, ma'am.
yes, if you divide 1 by 123, you'll get the value as 0.008. Both Rakshan and Muthulakshmi were right. So it is 0.008. And we know that upon complete dissociation, each calcium hydroxide will give you 2 times of OH minus ion. Right? So here the concentration of calcium hydroxide is 0.08. So upon complete dissociation, we'll get 2 times of OH minus ion. Right, Kana? So here we got the concentration of OH minus ion. So from concentration of OH minus ion, can you please calculate POH? Formula to calculate POH is minus log of OH minus ion. That's it. So what is the concentration of OH minus ion? 0.016. So this can be written as 1.6 into 10 power minus 2. So 1.6 into 10 power minus 2, or you can have it as 16 into 10 power minus 3. Anything is fine. Does your wish, Kana? You can take it as 1.6 into 10 power minus 2 or 16 into 10 power minus 3, because we can solve log 10, I mean log 16, and also we can solve log 1.6. Anything is fine. So what is POH? Lakshmi, it cannot be 0.76. There was some error, it seems. So here 2 minus log 1.6, right? So what will be the value of log 1.6? Log 1 is 0, log 2 is 0.3010. So log 1.6 must be between log 1 and log 2, right? So somewhere 0. You have to come up with the value between 0 and 0.3. Anything is fine. Tell me the value between 0 and 0.3.
0.19.
Okay, fine, 0.19. So 2 minus 0.19. What will be the answer? 1 point? Hmm.
1.81.
Okay, 1.81. Fine. So if this is the value of POH, could you please calculate the value of pH? Because they're asking for the value of pH. The relationship is pH plus pOH is equal to 14. And now we know the value of pH. So what will be the value of, we know the value of pOH and we have to calculate pH. So 14 minus pOH, which is 1.81. So answer is so which option is right? So which option is right, Kanna?
C, ma'am. C, ma'am.
Very good. It is option C. That's it. So shall we move on to next question? Okay, here also they're asking us to calculate the pH of the solution, and the data given here is 1 ml of 13.6 molar HCl is diluted with water to give 1 liter of solution. Here also they are giving the data how they have prepared HCl solution. Okay, there are two way of preparing a solution. One is they'll give you, we may have any solid and we'll be dissolving that solid in a particular quantity of water to prepare a solution. Another way is we'll be having a concentrated solution from which we'll be taking a particular quantity of solution and we'll be diluting it to give another concentration. So here this is the second pattern. Here they have a concentrated solution of HCl whose concentration is 13.6, and from which they have taken 1 ml and they are diluting it to 1 liter of the solution. So first job is we have to calculate the concentration of the new solution, and from that concentration of the solution we have to find H plus ion, and from which we have to calculate pH. And formula to do that is dilution formula, right? You would have studied in your some basic concepts of chemistry. V1 M1, which is equal to V2 M2. V1 is the volume of the stock solution, M1 is the concentration of the stock solution, V2 is the volume of the resultant solution, and M2 is the concentration of the resultant solution. So here V1 is 1 ml and M1 is 13.6 molarity, and volume of the resultant solution is 1 liter, and M2 to be calculated. Okay, so could you please tell me the concentration of the new solution? Tana, this is an ml and this is liters. Convert any of these. So convert milliliter to liter or liter to milliliter. Anything is fine.
Ma'am, 0.0136.
Okay, Kana, right. So H plus ion concentration is 0.0136. Very good. So this can be written as 1.36 into 10 power minus 2. Right, Kana? Here you will get the concentration as 0.0136 as the concentration of HCl, and upon complete dissociation, one HCl molecule will give one H plus ion. So here the total concentration is 0.013 molarity. Upon complete dissociation, we'll get 0.0136 molarity as H plus ion concentration. So from which we can calculate pH. So pH is minus log of 1.36 into 10 power minus 2. Please simplify this and tell me the value of pH. Value of pH. What is the value of pH? It is 2 minus log 1.36, right? So find the value of log 1.36, substitute it here and simplify. Rakshan, what is the answer? Rakshan, Mutalakshmi, send the machine. Okay, Mutalakshmi's answer is 1.9. Yes, it is right. That's it. Shall we move on to next question?
Yes, ma'am.
Okay, so we are done with second and fourth question already. And I want you guys to do first and third question as activity. Okay, here the first question, 2 grams of thallium hydroxide, which is a base, is dissolved in water to give 2-liter solution, and they're asking us to calculate pH. So the atomic weight of thallium, I'll give you the atomic weight of thallium from which you can calculate the molar mass of thallium hydroxide. So atomic weight of thallium is 204 gram per mole. So it is the atomic weight of thallium and not the molar mass of thallium hydroxide. So from this, you can calculate the concentration of thallium hydroxide. From this, you can calculate OH minus ion concentration, after which pOH, and finally pH. And third question is very simple. They are talking about sodium hydroxide. They've given you the weight and the volume of the solution, calculate the concentration, and finally pH of the solution. Okay, fine. Shall we move on to next pattern? Shall we? Okay. So the next pattern is calculate the pH of the resultant mixture. See, till now we have been discussing only acid or only basic solution, right? But here they are talking about the mixture in which they have mixed acid and base, and they are asking us to calculate the pH of the mixture. So let us talk about this first question. See, they are talking about calcium hydroxide and HCl. So calcium hydroxide is a base and HCl is an acid, and they are mixing these two systems together, and they're asking us to find the pH of the resultant solution. Calcium hydroxide, they have taken 10 ml of 0.2 molarity, and HCl 25 ml of 0.1 molarity. There are two different volumes of two different concentrations, but they are mixing it together and they're asking us to find the pH. So first, we have to know how this calcium hydroxide will react with HCl. See, HCl is an acid and calcium hydroxide is, of course, a base. So if you treat acid and base together, what kind of reaction we can expect? Obviously, it is a neutralization reaction, right? In neutralization reaction, we'll end up with salt and water. Could you please tell me the formula of salt obtained here? How this calcium hydroxide will get dissociated? Calcium 2 plus and 2 times of OH minus, right, Kana? And how this HCl will get dissociated? H plus and Cl minus. So calcium 2 plus ion will combine with chloride. So what will be the formula of calcium chloride? Formula of calcium chloride.
CaCl2, ma'am.
Very good. CaCl2, because the oxidation state of calcium is 2 plus, oxidation state of chloride is Cl minus 1. Upon criss-cross method, we'll get Ca1 and Cl2 too. So this is the formula of calcium chloride, and of course we'll end up with water as byproduct. Could you please balance this equation? So if you treat calcium hydroxide with HCl, we'll end up with calcium chloride and water. So this is the equation, and we have to balance this equation. So right side we have 2 times of chloride, and left side we have only 1 chloride. So this is 2 times of HCl. Okay. Next, calcium is balanced, chloride is balanced. How about oxygen and hydrogen? Left side we have 4 hydrogen atoms and 2 oxygen atoms. So right side we have only 2 hydrogen and only 1 oxygen atom. So 2 times of H2O. So this is the balanced equation, right? Okay, now what we can infer from this balanced equation is, see, 1 mole of calcium hydroxide is reacting with 2 moles of HCl to give 1 mole of calcium chloride and 2 moles of water. So here calcium hydroxide and HCl are reacting in 1:2 ratio. If calcium hydroxide is 1, then for complete neutralization, HCl quantity we required is 2 moles, right? If calcium hydroxide is 2 mole, then HCl what we need is 4 moles, right? And in the point of view of HCl, if the quantity of HCl is 2 moles, then calcium hydroxide need is half, right? So it is 1 mole, half of HCl, right, Kana? So this is what the inference is. So what is the given data? Calcium hydroxide they've used is 0.2 molarity and they've taken 10 ml. So they've given you the concentration and volume, but our inferences are in terms of number of moles. So from this given data, calculate the number of moles of calcium hydroxide taken. So how to do that? Formula is concentration is equal to number of moles by volume. So you have concentration and volume of the solution. Please, from this data, calculate the value of number of moles. So how to do that? Concentration of calcium hydroxide is 0.2 molarity. Molarity can be written as mole per liter. And volume of the solution is 10 milliliter, which is equal to number of moles. Liter and per liter will get cancelled. So 0.2 into 10 is 2. You should not forget this milli. So millimole. So number of moles of calcium hydroxide is taken is 2 millimole. Can you please calculate it for HCl? Can you please do it for HCl? What was the number of moles of HCl taken? Volume of the solution is 25 ml and concentration is 0.1 molarity. So 25 ml into 0.1 mole per liter. Yes, 2.5 millimole. 2.5 millimole. Okay. So from this data, we have to find which is the limiting reagent. Quantity of calcium hydroxide required is half of the quantity of HCl, or quantity of HCl required is 2 times the quantity of calcium hydroxide. That is the relationship between calcium hydroxide and HCl. Here, calcium hydroxide taken is 2 millimole. So how much HCl we required for complete neutralization? 2 times of calcium hydroxide's concentration, right? So since it is 2 millimole, HCl required is 4 millimole, but actually we have is just 2.5 millimole, right? So which is the limiting reagent here? Which is the limiting reagent here? Is it calcium hydroxide or HCl? Yes, it is HCl, right? Because what is limiting reagent? It is a reagent whose concentration is lesser than the actual quantity required. So here we need 4 millimole of HCl for complete neutralization, but unfortunately we have just 2.5 millimole of HCl. So that is the limiting reagent, and this will decide the quantity of the product formed. So if HCl's number of mole is 2, then you'll end up with 1 calcium chloride. Here HCl is 2.5 millimole. Upon complete neutralization, you'll end up with half the quantity of calcium chloride, right? So here all the HCl will get consumed, and how many millimole of calcium hydroxide will be unreacted? How much will be unreacted, Kanam? If 2 millimole of HCl was, or 2 moles of HCl was involved in the reaction, for complete neutralization, we need 1 mole of calcium hydroxide, right? Which is the half moles of HCl, right, Kana? Similarly, here HCl involved was 2.5 millimole. So how much number of moles of calcium hydroxide was involved in the reaction? How much was involved in the reaction? Half of 2.5 millimole, right? Yes. So can you please tell me how much quantity of calcium hydroxide was involved in the reaction, and how much is the remaining quantity? So 2.5 divided by 2 is? Um, so according to Muthulakshmi, the quantity of calcium hydroxide involved was 0.12, and remaining number of mole is 1.88. Kana, actually, see, number of moles of calcium hydroxide required is half the quantity of HCl, right? Here, the quantity of HCl is 2.5. So, how much quantity of calcium hydroxide required is half of 2.5, right? So, what is half of 2.5? What is 2.5 divided by 2?
1.25, ma'am.
Very good. It is 1.25. So in 2 millimole, 1.25 millimole was involved in the reaction. So how much quantity of calcium hydroxide was remaining inside the solution? 2 minus 1.25, right? Which is 0.75 millimole. Could you please tell me whether the solution is acidic or basic? Is it acidic or basic? In the solution, now we have salt, water, and unreacted calcium hydroxide. So now tell me whether the solution is acidic or basic. Yes, it is basic. Very good, because here we have unreacted calcium hydroxide. So this makes the solution basic. Now we have the number of moles of calcium hydroxide. So now we have to calculate the pH of the solution, right? So for that, see, we have number of moles of calcium hydroxide. From this, you have to calculate concentration of calcium hydroxide. And from this, we have to calculate the concentration of OH minus ion. From that, we have to calculate pOH and finally pH of the solution. So our job is to calculate calcium hydroxide now. So we have number of moles of calcium hydroxide. And what is the formula to calculate concentration? Concentration is equal to number of moles by volume. And here, what is the number of moles of calcium hydroxide? It is 0.75 millimole. And what is the volume of the solution, Kana? See, they have taken 10 ml of calcium hydroxide and 25 ml of HCl. So what is the total volume of the solution? It is 10 plus 25. It is 35 milliliter. So and milli will get cancelled. So what is the concentration, Kana? 0.75 divided by 35 mole per liter. Can you please simplify this? 0.75 divided by 35. See, 0.75 can be written as 75 into 10 power minus 2. Right, so it is easy for us to divide 75 and 35. Right, Kana? Can you please do that? 75 divided by 35. It's 2 point something, right? 2 point. Please come up with only one decimal after point. Yes, 2.1 into 10 power minus 2. Very good. So the concentration of calcium hydroxide is 2.1 into 10 power minus 2. Kana, this is the concentration of calcium hydroxide. Can you please tell me the concentration of OH minus ion? Because calcium hydroxide upon complete dissociation will end up with calcium 2 plus and 2 times of OH minus ion. So here the concentration of calcium hydroxide is approximately 2 into 10 power minus 2, right? So what will be the concentration of OH minus ion? 4 into 10 power minus 2. That's it. So from this we have to calculate POH. Can you please do that? It was 2.1 into 10 power minus 2. I've taken as 2 into 10 power minus 2 approximately, and from which I've calculated the concentration of OH minus ion as 4 into 10 power minus 2. And I want you to do the calculation part of POH. So what is the formula? Minus log of OH minus ion concentration. Easy. Now, what is POH? So Muthulakshmi's answer is 1.398. Brilliant. Yes. So approximately I'm having it as 1.4. So Muthulakshmi's answer is 1.398, which is the perfect one. I'm just rounding it off to 1.4. Now tell me the value of pH. pH.
12.
So 14 minus 1.4. Yes, Kanna?
12.6.
Very good. It is 12.6. That's it. So this is the pH of the solution. So we know obviously it will be a basic and the exact pH is 12.6. That's it. So first question is done. Among second and third, I want you guys to do one problem now, another problem as activity. Which problem you are doing it now? Second or third? Shall we do second problem? Uh, do second problem now and do third problem as activity. So solve this question, Kana. 10 ml of 0.1 molar sulfuric acid is mixed with 10 ml of 0.01 molar calcium hydroxide. So you have to write the neutralization reaction between sulfuric acid and calcium hydroxide. Please balance that equation, and you have to infer from the balanced equation. From that inference, you have to infer, and after which write the given data and find the limiting reagent and find the solution, whether it is acidic or basic, or find the remaining unreacted system. Done with balanced equation? Can you please tell me the balanced equation? So here the neutralization reaction is between sulfuric acid and calcium hydroxide. So what salt we'll be getting here? Calcium sulfate. So what is the formula of calcium sulfate? Yes, CaSO4 and water. So I want you, calcium is balanced, sulfate is balanced, hydrogen and oxygen yet to be balanced. So 2 moles of H2O, right, Kana? So what is the inference in terms of number of moles? 1 mole of sulfuric acid is reacting with 1 mole of calcium hydroxide to give 1 mole of calcium sulfate salt and 2 moles of water. Here, sulfuric acid and calcium hydroxide is reacting in 1:1 ratio. So according to this data, what is the number of moles of sulfuric acid involved? They have taken 10 ml of 0.01 molar sulfuric acid. So could you please tell me the number of moles of sulfuric acid involved? Number of moles of sulfuric acid involved.
0.01 mole.
0. Come again, Rakshan. I want it in terms of millimole. Yes, 0.1 millimole. So number of moles of sulfuric acid involved is 0.1 millimole. And number of moles of calcium hydroxide is also the same, right? 0.1 millimole. Is there any limiting reagent here? Is there any limiting reagent? No. So all the sulfuric acid will get consumed. So we will not have any unreacted acid or base. So we'll end up with 0.001 millimole of salt and water. So this is just the salt and water. So if you have only water, then what will be the pH, Kana? What will be the pH? Basically, the
7.
system is neutral. Yes, very good. So basically, the system is neutral. So the pH of the solution is 7. That's it. That's it. Okay. And please do this problem as activity. Okay. Shall we move on to next pattern? Right. So the next pattern is calculate the pH of a solution formed by mixing equal volumes of two solutions A and B of strong acid having pH 6 and pH 4 respectively. See, here also they are talking about a mixture, but here they are mixing two acids. In previous case, they mixed one acid with base, right? Here they are mixing two acids of different pH values, and they are asking us to calculate the pH of the resultant solution. So how we can do is, see, I have a solution A whose pH is 6, and I have another solution B of pH 4. Now we're going to mix these two solutions together. See, they're talking about equal volumes. If I take 10 ml of A, similarly I have to take 10 ml of B. So totally 20 ml together, right? So here, if the pH is 6, then what will be the concentration of H plus ion? If pH is 6, then what will be the concentration of H plus ion in the solution? If pH is 6, then what will be the concentration of H plus ion? pH is equal to 6. pH can be written as minus log of H plus ion. So log of H plus ion is minus 6. So H plus ion is, if you bring log to right side, it will become as 10 power minus 6. Since 6 is a whole number, we can do like this. Anti-log is not necessary. So concentration of H plus ion is 10 power minus 6. Here, the concentration of H plus ion is, in second solution, what will be the concentration of H plus ion?
4.
Very good. It is 10 power minus 4. Now we are mixing both solution. So in the resultant solution, total H plus ion will be 10 power minus 6 plus 10 power minus 4, right? So in the resultant solution or in the final solution, total H plus ion will be sum of 10 power minus 6 and 10 power minus 4, right, Kana? But here we are mixing two solutions of equal volume, because of which the total volume of the solution will get increases by 2 times, right? See, what is the formula of concentration? Concentration is equal to number of moles by volume. Here, volume of the solution and concentration were inversely proportional. Here, upon mixing two solutions of equal volume, volume of the solution is getting increases by 2 times. See, initially, for example, initially the volume was 10 ml, and here also the volume is 10 ml. If you mix both the solutions, then we'll end up with 20 ml of the solution. The volume of the resultant solution is 2 times the volume of the original one, right? So here, accordingly, volume will be increases by 2 times. So concentration will get decreases by 2 times, right? So 10 power minus 6 plus 10 power minus 4 will not be your concentration. Definitely you have to divide this by 2, because whenever the volume is increases by 2 times, then the concentration will get decreased by 2 times. That is why I'm dividing it with 2. In a different problem, if they are talking about mixing 3 solutions of equal volume, then you have to divide it by 3. Okay, fine. So you have to add this 10 power minus 4 and 10 power minus 6. Kana, while you're adding, please make sure you have same powers on 10. So either make 10 power minus 6 as 10 power minus 4 or 10 power minus 4 as 10 power minus 6. So convert that accordingly and add both the values and divide it with 2 to find the original H plus ion concentration, which is easy for you. 10 power minus 6. Shall we convert 10 power minus 4 to 10 power minus 6? That is 1 into 10 power minus 4, right? So 1 into 10 power minus 4 can be written as, I want that into 10 power, in terms of 10 power minus 6, Kanna. Have to do that? Okay. So this can be written as 100 into 10 power minus 6, right? So 100 into 10 power minus 6 divided by 2. So from this we can take 10 power minus 6 common. So 1 plus 100 divided by 2. So 1 plus 100 is nothing but 101 into 10 power minus 6 divided by 2. Approximately, I can have this 101 as 100 into 10 power minus 6 divided by 2. So if you divide 100 by 2, it is 50. So 50 into 10 power minus 6 is the H plus ion concentration. So from that value, please calculate pH. So H plus ion concentration is 50 into 10 power minus 6. That can be written as 5 into 10 power minus 5, right? So because 50 can be written as 5 into 10. So 10 into 10 power minus 6 is 10 power minus 5. So 5 into 10 power minus 5. Please calculate the pH. Easy. Minus log of 5 into 10 power minus 5. Muthulakshmi's answer is 4.31. How about Rakshan?
I'm getting
Okay, fine.
4.4,
Approximately it
ma'am.
is 4.3 according to our option. Okay. Mushkan, Sendamit Shelvan, Sharmila. Are you guys getting 4.3 approximately? Sendamit Shelvan?
Yes, ma'am.
Okay. So the final answer is 4.3. That's it. Okay. Shall we move on to next question? Okay, next question is, okay, the question is pH of 10 power minus 8 molar HCl at 25 degrees Celsius. The question is about HCl and the concentration is given as 10 power minus 8 molarity, and we have to calculate pH of the solution. What pH you are getting? See, if it is not matches with the option also, please tell me what pH you are getting.
Slightly greater than 7.
Okay, slightly greater than 7. Okay, because you are getting more than 7. So you're telling the answer is option D. Okay, fine. That was a good try, Rakshan. Sharmila, Sendamil Shelvan.
Ma'am, slightly less than 7, ma'am.
Okay, why you changed the option?
Ma'am, I
Why
didn't
it
see
shouldn't be
it
option
as.
4?
Ma'am,
Hmm. Why
I
it
thought
shouldn't be
it's
option
base,
4?
ma'am.
Okay, right. Rakshan was right because see, HCl is an acid. Anyways, pH has to be less than 7. For any acidic solution, pH will be between 1 and 7, right? Here, the concentration is 10 power minus 8 molarity, whose concentration is extremely low. Even though the concentration is less, we cannot tell it will be base, right? See, normally how we'll be doing it is HCl is a strong acid. Upon complete dissociation, we'll end up with H plus ion and Cl minus ion. Here, the concentration of HCl is 10 power minus 8 molarity. So, HCl upon complete dissociation, we'll get 10 power minus 8 molarity as H plus ion. And what is the formula to calculate pH? Minus log of H plus ion. So, minus log of 10 power minus 8. So, pH is 8. So this is what our actual calculation is. But HCl is an acid and it cannot be 8, whose pH cannot be 8, right? So there is some mistake in it, right? So definitely answer is not 8. So that is why Rakshan told me the answer is not option 4, slightly less than 7. But why we got it as 8? Somewhere something is missing, right? I'll teach you now. Listen here. Now forget this question. I have an acid solution whose concentration is 10 power minus 1 molarity. Okay, could you please tell me the pH of the solution? If HCl's concentration is 10 power minus 1 molarity, then what will be the pH of the solution? If the concentration of HCl is 10 power minus 1 molarity, then what will be the pH of the solution?
1, ma'am.
Yes, it is 1. Right, Kana? Now we are getting a perfect answer. But not in this. Whenever you are preparing an acid solution, what we are doing? We are mixing acid with water, right? So HCl is mixed with H2O. This is the solution, right? See, according to this data, 10 power minus 1 molar HCl, I mean 10 power minus 1 molar HCl is giving 10 power 1 molar HCl is giving 10 power minus 1 molarity of H plus ion. Similarly, water also it will get dissociated. So H2O it will get dissociated into H plus and OH minus ion. But H2O is still dissociation. If you have a beaker full of water and the temperature is 25 degrees Celsius, water molecule will get dissociated into H plus and OH minus ion. But that will be a partial dissociation. At 25 degrees Celsius, this system will have H plus ion concentration as 10 power minus 7 molarity. If concentration of H plus ion is 10 power minus 7 molarity, then what will be the concentration of OH minus ion? What will be the concentration of OH minus ion? one water molecule will give one H plus ion and one OH minus ion, and concentration of H plus and OH minus ion will be the same, right? So if the concentration of H plus ion is 10 power minus 7, then concentration of OH minus is also 10 power minus 7. Okay. Now we'll come back to this problem. So H plus ion from HCl is 10 power minus 1 molarity, and from water we'll be getting 10 power minus 7 molar H plus ion. So what is the total H plus ion in the solution? 10 power minus 1. Value or the magnitude between these two systems, see, this is a very lesser number if you compare it with 10 power minus 1. So that is why you're neglecting it. So this tends to 0. So what will be the H plus ion concentration? Approximately it is 10 power minus 1. So that is why pH is equal to 1. But in our problem, in this problem, HCl is mixed with water, and according to the data, H plus ion from HCl is 10 power minus 8. Then what will be the concentration of H plus ion from water? It is 10 power minus 7. In fact, the H plus ion concentration from water is higher than the concentration of HCl. Right, Kanan? Now we cannot neglect the H plus ion from water. So total H plus ion concentration in the solution is 10 power minus 8 plus 10 power minus 7. Here you shouldn't neglect the concentration of H plus ion from water. So if you add both the values, what we can get is, first we have to convert 10 power minus 7 to 10 power minus 8, which is 10 into 10 power minus 8. So we can take 10 power minus 8 is common. So 1 plus 10 is 11. So H plus ion concentration is 11 into 10 power minus 8, or I can write it as 1.1 into 10 power minus 7. So this is the H plus ion concentration. So from which we can calculate pH. So what is the formula to calculate pH? pH is equal to minus log of H plus ion concentration, and H plus ion concentration here is 1.1 into 10 power minus 7. So if you simplify this, 7 minus log 1.1. So from 7 you have to subtract a quantity which is 1.1. So the value of log 1 is 0, value of log 2 is 0.3010, and here we have just 1.1. So value will be 0. It will be very lesser value, right? So we have to tell between 0 and 0.3. It can be around at least 0.1, right? So it is a very approximate value. So you'll be getting it as 6.9, right? Actually it will be less than 0.1 actually, right? So here you are getting it as 6.9 and it is less than 7. So answer is option C. Okay, so here that is what the problem. Whenever the concentration of acid is 10 power minus 6 molarity or less than that, please include the H plus ion from water also. Then only you'll get the exact pH of the solution. Okay, normally we will not do that because H plus ion from water will be very much lesser, so we'll be neglecting it. But whenever the concentration of acid is 10 power minus 6 or less than 10 power minus 6 molarity, please include the H plus ion from water also. That's it. Any doubt? Any doubt, Kana? Fine. So we are done with different pattern of pH related problem as far as strong acids and strong bases are concerned. Now we'll move on to weaker systems, okay? Weaker electrolytes or weaker acid, weak bases. Okay. So to do that, we'll start with a law called Ostwald's dilution law. Ostwald's dilution law. Okay, let us take any weak acid. Okay, I'm going to have it as HA. It is a hypothetical acid. So upon dissociation, we'll end up with H plus ion and A minus ion. Since it is a weak acid, we can expect only partial dissociation, right? So since the system is in equilibrium, we can write a equilibrium constant which is capital K. Since it is for acid, I'm going to have it as Ka. Ka is nothing but it is an equilibrium constant, or it can also called as ionization constant, or this can also be called as dissociation constant or acid dissociation constant. We can use 4 terms for this Ka. Please make a note of it. Ka can be, or K is called equilibrium constant or ionization constant or dissociation constant or acid dissociation constant. Fine. So how we can express this Ka? Basically, it is an equilibrium constant, and expression for equilibrium constant is concentration of product divided by reactant. So here, product is H plus ion and A minus ion divided by concentration of Ha. So from this relationship, what we can infer is, Kana, here we are talking about weak acids. Okay, if you compare two different weak acids, now we're going to compare the strength of the two weak acids. So if we are provided with the H plus ion concentration of each acid, what we can tell is the acid which got lesser H plus ion concentration will be considered to be the weakest one, right? So the something which releases H plus ion, it is considered to be an acid, and if the system releases less number of H plus ion, then that is considered to be the weaker one, right? So if the concentration of H plus ion is less, then the acidic strength is less. If the H plus ion concentration is more, then acidic strength will be more. Right. Similarly, we can predict the acidic strength not only from the H plus ion's concentration, we can also predict using pH. We can also predict using Ka values. For all the weak acids, we'll be having Ka values, and from the Ka value also we can predict the strength of an acid. See how we can do that is, in this relationship, what we can infer, Kana, H plus ion concentration is directly proportional to Ka, right? For relatively a stronger acid will have more number of H plus ion. If the concentration of H plus ion is more, then the value of Ka will be more, right? So if the value of K is greater, then acidic strength also will be more, right? And how about pH? How about pH? How about pH? What is the formula? pH is equal to minus log of H plus ion. Could you please tell me how this H plus ion and pH are related? Are they directly proportional or inversely proportional? How this H plus ion and pH are related, Kana? Are they directly
Directly
proportional?
proportional.
Sorry, Sindhama Chelvan, I couldn't hear you.
Directly proportional, ma'am.
Okay. Okay, Muthulakshmi's answer is inversely proportional. Then shall we check this? Okay, I'll give you a few H plus ion concentrations and I want you to tell me the pH of the solution. In first case, H plus ion concentration is 10 power minus 2. And in second case, H plus ion concentration is 10 power minus 4. And in another case, H plus ion concentration is 10 power minus 5. Could you please calculate the pH of all the solution?
2, 4, 5.
Ma'am, it's inversely proportional, ma'am.
2, 4, 5. So if the concentration of H plus ion decreases, pH increases. So they are inversely proportional. So for more acidic strength, H plus ion concentration should be more and pH should be less. So H plus ion concentration and pH are inversely proportional. Similarly, pKa is nothing but, instead of P, I can write it as minus log Ka. That's it. Then tell me how Ka and pKa are related. How Ka and pKa are related? Are they directly or inversely proportional? Here also we have negative sign, right? So Ka value is inversely proportional to pKa. So if an acid got lowest pKa, then that seems to be acidic one, more acidic. Okay, this is the relationship, and very important relationship, Kana. We're going to use this relationship in organic chemistry also. We'll be using it in alcohol phenol ether, and also we'll be using it in carboxylic acid chapter. Fine. Any doubt till now? Any doubt? Fine. Same thing, I can use it for weak bases also. For example, the weak base I'm going to take is MOH. Since it is a weaker one, it will dissociate partially, and we'll end up with M plus and OH minus ion. And here the equilibrium constant is Kb. Please make a note of it. Kb is nothing but equilibrium constant. Equilibrium constant, ionization constant, or dissociation constant, or base dissociation constant. Base dissociation constant. That's it. So now we're going to write the expression for Kb as concentration of product, which is M plus and OH minus ion, divided by concentration of MOH. Now, based on this relationship, the inferences are, if the system releases more number of OH minus ion, if the concentration of OH minus ion is more, then basic strength will be more. If OH minus ion concentration is more, then it is directly proportional to Kb. So the value of Kb also will be more. Then what is POH minus log of OH minus ion concentration? And here OH minus ion concentration, POH are again inversely proportional. So if the concentration of OH minus ion is more, then POH will be less. And how about pKb? It is very similar to our pOH. It is minus log of Kb. So higher the concentration of Kb, lower will be the value of pKb. So if the system got lowest pKb, then that system got highest basic strength. That's it. And this relationship, we'll be using it in the chapter called amines and 12 standard. Fine. So this is Ostwald's dilution law. And here I've just written the relationship. I have a very small derivation here. Listen here. If the concentration of HA before dissociation was C, when time t is equal to 0, the concentration of weak acid I've taken is 0. Before dissociation, there will not be any H plus ion or A minus ion. But when the system is at equilibrium, a particular quantity of HA would have dissociated, right, Kana? So if the quantity of acid dissociated was C alpha, then what will be the remaining quantity of HA? The quantity dissociated was C alpha. Then what will be the remaining quantity of weak acid? What will be the remaining quantity? See, I have 100 molecule of A. That is getting converted into product P. In 100 molecule of A, 30 molecule was involved in the reaction. Then what will be the remaining quantity of A? If 30 was involved in the reaction, then what will be the quantity of A? Initial quantity was 100, in which 30 molecule was involved in the reaction. Then what will be the remaining quantity of A? How much? Is it still confusing? Yes, Muthulakshmi is right. It is 70. Because I've taken 100 molecules initially, in which 30 molecules involved in the reaction. So the unreacted molecule is 100 minus 30, which is 70. Similarly, here I have taken a HA as C concentration and in which C alpha was involved in the reaction. So the remaining quantity will be C minus C alpha. Okay, then what will be the quantity of H plus ion and A minus ion? It is C alpha and C alpha again. Okay, what is alpha, Kana? We know what is C. It is the concentration of acid. What is alpha? This we discussed in last class. Alpha. It is degree of dissociation. Yes, very good. It is degree of dissociation. Okay. How randomly I told C alpha was involved in the reaction? Randomly I told C alpha was involved, right? But how the C alpha came? Shall we check? Listen here. See, HA was the initial, HA was the weak acid. And upon complete dissociation, it will give H plus ion. Upon partial dissociation, we end up with H plus ion and A minus ion. And I've taken C concentration. And before dissociation, it will be 0 each. And would have involved in the reaction, right? Let us take it as X. We don't know how much quantity it was, so I'm going to have it as X. So what will be the remaining quantity of HA? In C concentration, X concentration was involved in the reaction. So what will be the remaining quantity of HA? It was C, in which X quantity was involved. We don't know how much quantity it is. So what will be the remaining quantity? Rakshan, Sendamil Shelvan, what will be the remaining quantity? See, the initial concentration is C. And some quantity was involved in the reaction. But we don't know how much was that. I'm going to have it as X. If X quantity or X concentration of HA was involved in the reaction, then what will be the remaining quantity of HA? It will be C minus X. Right, Kana? And what will be the quantity of H plus ion formed? X and X. Right? I've just written the X in terms of C alpha. I'm just asking what is the relationship between this X and C alpha. Okay, we'll see what is the relationship. Okay, what is alpha actually? What is alpha? I've told you the formula for alpha in our last class. Alpha is the number of moles of electrolyte dissociated divided by number of moles of electrolyte added in the solution. So number of moles of electrolyte added was C here. And quantity of electrolyte involved was X, right, Kana? So what is the X then? C into alpha. So that is why I've written the X in terms of C alpha here, degree of dissociation. That's it. Now we're going to apply these concentration terms in this expression. So C minus C alpha can be written as C into 1 minus alpha. So Ka is equal to concentration of H plus ion is C alpha, concentration of A minus ion is again C alpha, divided by C into 1 minus alpha. C will get cancelled. So the value of Ka is alpha square C divided by 1 minus alpha. Kana, for weakest electrolyte, what will be the value of alpha? Alpha will be 1 for strong electrolyte. Here we are not talking about any strong electrolytes for which Ka is not applicable. So we are not going to talk about strong electrolytes. But for weak electrolyte, alpha will be less than 1, right? So if suppose alpha is very much less than 1, here alpha tends to 0. So what is Ka? Alpha square C. That's it. So this is a very important formula which relates dissociation constant and degree of dissociation. Kana students used to confuse between degree of dissociation and dissociation constant. Degree of dissociation is alpha and dissociation constant is Ka. Please don't get confused between alpha and Ka. They are two different terms. Degree of dissociation is alpha and dissociation constant is Ka. Here I've derived the relationship for acid. Same thing is applicable for base also. As far as base is concerned, the formula will be Ka is equal to alpha square C. That's it. Okay. Fine. Any doubt? Any doubt till now? Any doubt?
No.
Fine. So we have 5 more minutes. Shall we do one more derivation? If you guys are okay, we'll do one more derivation. Or else we'll wind up the session. Okay, fine. Muthulakshmi is okay with it. How about Rakshan, Sendamil children? If you guys are tired, please let me know. We'll wind up.
Yes, ma'am. We can do it, ma'am.
Not head.
Okay, shall we continue then? Okay, one small concept which is called ionic product of water. Ionic product of water. So now we're going to talk about H2O. As I've told you already, H2O is a weakest electrolyte. But since it is an electrolyte, it will get dissociated into H plus ion and OH minus ion. Since it is a weaker one, we can expect only partial dissociation. So this is pure liquid and it will get dissociated into water. So this is an aqueous medium. So since the system is an equilibrium, we can write an equilibrium constant K, and it is concentration of product divided by concentration of reactant. Here the reactant is H2O, which is a pure liquid, and we know the concentration of pure solids and liquids are unity. So here the concentration of water is 1, which is a constant, and K is also another constant. If you cross multiply these two terms, if you multiply two constants, we'll end up with another constant. So I'm going to have it as Kw. Kw is equal to H plus ion into OH minus ion. This is one of the important formulas. And Kw is nothing but ionic product of water. Fine. So this is equation number 1. What I've told you, if I have a beaker full of water, and if the temperature of this water is 25 degrees Celsius, water will get dissociated and we'll be having H plus ion and OH minus ion. And the concentration of H plus ion and concentration of OH minus ion at 25 degrees Celsius is
10 power minus 7, ma'am.
very good, Kana. So concentration of H plus ion is 10 power minus 7 molarity, and concentration of OH minus also 10 power minus 7 molarity. So at 25 degrees Celsius, then what will be the value of Kw? 10 power minus 7 into 10 power minus 7. So Kw value is 10 power minus 14. Now we're going to calculate pKw. pKw is nothing but, instead of P, I can write it as minus log Kw. Could you please calculate, Kana? Kw value is 10 power minus 14. Then what will be the value of pKw?
14.
14.
Very good, it is 14. Whenever the temperature is 25 degrees Celsius, then Kw value is 10 power minus 14 and pKw value is 14. If suppose the temperature is more than 25, then if the temperature is higher, then dissociation will be more. Then concentration of H plus ion and OH minus ion will get increased. It increased to 10 power minus 6, 10 power minus 5, 10 power minus 4. So whenever the temperature is increased or decreased, then we have to change the values of Kw and pKw accordingly. Okay, fine. So we got the value of Kw and pKw. Now we're going to derive a value equal to H plus ion into OH minus ion. Left side and right side, I'm going to multiply it with minus log. So minus log of Kw into minus log of H plus ion and OH minus ion. So what is minus log of Kw?
Fourteen, ma'am.
What is minus log of Kw? It is pKw, right? So minus of, this is like log A into B. This can be written as log A plus log B. That's it. So what is the value of pKw, Kana? It is 14. 14 is equal to minus log of H plus ion minus into plus log of OH minus ion. So 14 is equal to, what is minus log of pH, I mean minus log of H plus ion? That is pH. Plus what is minus log of OH minus ion? That is pOH. That's it. This is how we got this formula. pH plus pOH is equal to 14. That's it. Now we know what is Kw and we know what is Ka, which is acid dissociation constant, and we know what is Kb, which is base dissociation constant. If you multiply Ka and Kb, you'll end up with the value of Kw. This is also a very important relationship. That's it. So we are done with Ostwald's dilution law and ionic product of water. And in next class, we'll be discussing numerical related to these concepts. Okay. Fine. Do you have any doubt? Please ask me, Kanna. Else we'll wind up the session. Rakshan, Mutlakshmi. Okay, Sandamil Shelvan, Sharmila, Mushkan.
No, ma'am.
Fine. Okay, Kanna. Then
Thank
we'll
you.
meet in our next class. Bye, Kanna. Bye. Good night.